Hello revivers! Welcome back. As this is going to be the last topic of this chapter, it's time to have some fun! Wait, what? Not this sort of fun? Fun while learning. As promised, we are going to perform an activity to use Ohm's law in real world. Any guesses what we are going to do today? I know how hard you are thinking. We'll be making a circuit to light up the LED. But beware, don't blow it up. Don't worry, I'll tell you the secret to keep the LED safe. But for now, let's focus on the activity. You'll need a resistor whose value we'll be discussing shortly, 2 male to female jumper cables, an LED, and last but not the least, the heart, body and soul of your activity, Revive! All these components will be present in your starter kit. Let's begin with the explanation. First, we'll open up the magic lid. As soon as we open it up, we'll see a small board with teeny tiny holes placed neatly in the rows. This is known as breadboard. They are extremely necessary whenever we learn how to build a circuit. What? Because the circuit we make using them does not require soldering, as breadboard have vertical metal strips. These strips have clips below them, which allows you to insert the wire or the leg of the component. All the components inserted in the clips of one metal strips are connected with each other as the same current flows through this clip. This reduces the use of soldering. If you make any mistakes, you can easily change the circuit. So let's get started with the activity. For that, take one of the cable and insert its female end into the positive terminal of 5 volts. Take its free end and insert into the first column and first row of the breadboard. Then take the LED of your choice and insert its positive terminal, that's the longer leg, into the next row of the same column. Then take the resistance of 220 ohms and insert it into the next row of the same column where we inserted the negative terminal of the LED. Similarly, take the other cable and insert its male end into the next row of the same column where the other end of the resistor was connected. Finally, take the free end of the cable and insert into the negative terminal of 5 volt. Finally, switch on the Revive. This will light up your LED. We saw half of the circuit. It's time to see why. Do you even wonder why did we use 220 ohm resistor or why even resistors? Let me tell you why. Have a look at LED. Depending on the color, it requires voltage in the range of 1.5 volts to 4 volt. The Revive provides a constant of 5 volt. This means that the current will be higher, which may blow up your LED. This is where resistor came into the rescue. It will limit the current flowing in the circuit. You must find out the minimum amount of resistance to keep the current below 0.02 ampere. If we connect resistor in series with LED, there will be voltage drop across the resistor. That is, at one end, if the voltage is 5 volt, then the other end, the voltage drop will be 3 volts, which will be provided to your LED. Suppose an LED requires 2 volts, therefore the voltage drop across the resistor will be 3 volts. And from the previous video, we saw that the current should not be more than 0.02 amperes. By using Ohm's law, we can calculate the resistance as R equals to V by I, which equals to 3 by 0.02. That is equal to 3 into 1000 by 20, which gives you 150 ohms. Therefore, we must connect a resistor of at least 150 ohms. Any value greater than this will keep your LED safe. From the starter kit, you'll find the resistor of 220 ohms. That is the reason why we used it. We are done for the day. But before we part, I have an assignment for you. We use the resistor of 220 ohm. Now it is your job to find out what happens when we connect resistors higher than this value. Or you can even try series and parallel connection. Till that time, I and Neo are going to party. Bye-bye. Lots of love.